Alright, well welcome to our first video for the SEP 6th, 7th, and 8th for Plus. What I want to start us off with is talking about what is science and how we can use it as a tool both in our classrooms and particularly for our students. Now, I'm not going to pretend that you all don't already know what science is, but it might surprise you how many preconceived notions even us as teachers have about what science is and how we use it. This is a game that was played on me during a hike in the Linville Gorge, and I failed. And ever since, I have been using it on the first day of true instruction in each of the science classes that I teach. So up here, I've got a link that you can follow. Feel free to use this. I presented at the AMLE conference a couple of years ago about using argumentation in the science classroom. I am going to be borrowing from this presentation that I did on a couple of our other videos as well, but I figured I'd go ahead and put this up here. Now I will say, don't skip ahead past the second slide because I don't want to give it away. If you're a Veritasium subscriber, you may have already seen this, but if you haven't, I felt like it's a good way to kind of get us started and to get us really thinking about what science is and how we can use it. So I've got my lovely assistant here for our first video who has told me that she has not done this activity before, so we're going to see and test her scientific prowess on screen for the first time. Nothing like live recorded video to be able to get that done. So what I'm going to do is I'm going to give you a series of 3 numbers. So I'm going to write those numbers on the board. Okay, so you've got 3 numbers. Now, you're a scientist. What your goal is to determine what is the rule that governs these 3 numbers. So your purpose is to determine the rule. Now, if you were to design an experiment to determine the rule, how might you go about that?
Determine an experiment. Maybe figure out the missing?
Okay, is there missing numbers? So we're going to start asking some questions about this. Let me try to, for the sake of time, simplify this and give you a little bit of direction. You can try to continue the sequence, or you can provide a whole new series of 3 numbers and that you think would fit the rule, or what you would think would not fit the rule, however you want to go about trying to determine what the rule is. Okay? So you give me 3 numbers and I'll tell you if it fits the rule or not. You can continue the series of numbers or you can come up with a brand new series of numbers.
Okay, so I just go with 10.
10. Okay, 3
10,
numbers.
12, 14.
So you want do 10, 12, and 14. And we're not saying whether or not this is necessarily continuing or whatever, but this is, do these numbers fit the rule? Yes, they fit the rule. Okay, now you can continue to experiment, or you can hypothesize as to what the rule is. And I will tell you if you get the rule or not.
Are we doubling?
Okay, 2, 4, and 8 are doubled. 10, 12, and 14 are not, and they both fit the rule. So I'll go ahead and write that down just so that we can know. And I would do this in my classroom as well, as kind of keep a general track as to what has been said. Doubling? No, not doubling.
Well, I like sequential, but the 4
Sure.
and the 8 do not fit.
Right. But neither does the 2 and 4.
So, just even numbers?
Okay, are they even numbers? Now, so far, what you've done would demonstrate that might be a possibility. I'm going to say No.
Oh,
Would you like to present a new series of 3 numbers? You can do that as many times as you'd like and continue the experimentation.
let's make it easy. Let's go 1, 2, 3.
Okay? Does 1, 2, and 3 fit the rule? It does.
You are stumping me.
So,
I don't know what. It's got less than, like a less than 10 rule, or does it add up?
okay, well, how about this? Before you do another guess, present another series of 3 numbers, and I'll tell you if it fits it or not, and then that way you can test your hypothesis. So if you're thinking less than 10, what would you do to determine if that is the rule or not? Because 12 and 14 are above 10, and I did say that those fit the rule.
What about larger numbers, like 100?
Okay, 100,
And then do like 102, 104.
102, 104 fits the rule. So the question remains, what is the rule? So let's take a pause real quick from the numbers, because numbers, as scientists, we're not always number people. We should be, but I understand. I'm not always that way myself. If I, truth be told, I'll pull out my phone as a calculator or ask my wife because she can run those numbers very quickly in her head. Think about this as if this were an experiment that you're running on the table. If you continue to get a positive result, yes, this fits with my hypothesis, even though you continue to run a multitude of tests, how would you verify that your hypothesis is correct?
Ask the teacher.
All right, ask the teacher. All right, so that would certainly be one way to do it. I'll give you a hint. Try giving me a series of numbers you think do not fit your rule.
Do not fit. All right, maybe like 50.
Okay, 50,
62.
62,
73.
73 fits the rule.
Well, then you have me.
Not yet. Try it 1 or 2 more times. Give me another series of numbers, because imagine, we just did an experiment here on the table. You didn't think that was going to fit with your hypothesis, and the equation still worked.
Do they have to be in increasing order?
Ah, you got it. It is in increasing order. It is in increasing order going up. But what I want you to, that's kind of this direction, increasing. But for verification's sake, we are scientists. Give me a series of numbers that does not fit this.
You can do like 10,
Okay,
8,
10, 8,
and then 50.
50 does not fit the rule because we go down and then back up. You could do 1, 2, 3, which you did, 2, 4, 8. One thing I appreciate about this, and you can tell generally who's been a science teacher longer, is because they don't just go for the instantaneously easy answer. Okay, because oftentimes, and what you'll see in the video, if you continue playing through this, it'll be on slide 3, would be that the majority of people that are interviewed in the video when this is done in public, 2, 4, 8, they continue with 16, 32, 64. And they just try to continue with the sequence. And in that case, the individual who runs this says, well, yes, that works. And they say, well, you're just doubling the number. But that's not it. And they will continue, okay, 100, 200, 300, or whatever, and they keep doubling it because, and students do this very frequently, is they'll get something in their mind and they'll say, okay, that's got to be the explanation. Or that's the explanation that makes the most sense not only to them, it might have even been something that was given to them by a previous instructor. And we have to kind of deconstruct this just enough for us to say, okay, it's not this. And how do we get them to do that? By trying to disprove their hypothesis. And this is what we come up with, which is a null hypothesis. And anyone who tells you that the purpose of science is to try to prove something doesn't understand science. So back it up just a bit, and your purpose in science is to try to disprove something. If you read one of the books that's mentioned in the video is The Black Swan, and it's by Nassim, I have to double check, I'll make sure to link that with this, is all about when explorers in all of the places that they had gone only ever saw white swans, so they kept confirming their bias. White swans are the only things that exist if we're looking at swans, until that they visited Australia and they determined that there are black swans. And that shifted their worldview so drastically that they had to go back and redo scientific literature for decades. So just something for us to think about, kind of a fun, quick experiment, a great way to ice break a class, particularly with new students. I hope you all enjoy.